All right, let's look at this problem. So here we have a similar situation where we have a voltage VC equal to 10 cosine 2000 pi t plus an angle of 0. Okay, and our capacitance is 10 microfarads. And similar to the last problem, they want us to find the complex impedance, phasor voltage, and current, and then write the current as a function of time, and then state the phase relationship. Okay, so let's go and do that. Let's find the complex impedance first. So that'll be negative j over omega c, or 1 over j omega c. That will be negative j omega. It's going to be 2000 pi radians a second. C will be 10 microfarads. Okay. And then that will give us negative J 15.915 ohms. Okay. And that's our complex impedance. All right, let's move on to the next part. So our VC is just going to be equal to the 10 and angle 0. And that's just pulling it straight from up here. So 10 and then angle 0. Okay, because that is the voltage of C. All right, so that part's done. Now to find the current. So similar to the last problem, we'll just do VC divided by ZC. Remember how we said that J is equal to 90 degrees, so therefore negative J is equal to negative 90 degrees. Okay. So then we'll have 10 at angle 0, 15.915 at angle negative 90. So 10 divided by 15.915, 0 minus negative 90. That'll give us 0.628 at an angle of 90. And that is our complex currents right there. Okay. Then we need to write this as a function of time. So I of C t will be 0.628 cosine. Remember, it's always cosine. 2000 pi, and that 2000 pi is the same frequency as before. So 2000 pi t at an angle of plus 90 degrees. Oh, and don't forget the units, amps. That should be amps up there. Volts. There we are. Now let's go and draw our shapes, a little diagram one more time, so just so we can represent it. The voltage of C here, V of C at angle 0, and then the current I of C at an angle of 90 degrees. So I of C at 90 degrees. So therefore, right here, that's a 90 degree difference. So we can say that the current leads voltage by 90 degrees. Or you can say the voltage lags current by 90 degrees as well. that is also fine. I would check it with Eli the Iceman. So ICE, ICE, and then ICI, ICE, where this is the current, this is the voltage, and here is our capacitor. So this means that our current leads our voltage, what we have here, or our voltage lags our current, which is what we have here. So we are looking good. All right. So it's pretty similar as the previous problem, but just now with the capacitance, you can see where that the Eli the Iceman, those leading, lagging things come into play. All right, I'll see you in the next problem.